So this is the standalone lesson. It's the formula at the top of the formula sheet. So it's theta equals A over R. So copy that down. All right. So A is the arc length. Okay, guys. R is the radius. So arc length and radius. And then theta is your angle. Now we're going to talk about what that angle needs to be in. So let's pretend off to the side that I gave you an arc length and I gave you a radius. Just over here, just to decide maybe that we can figure out what this theta has to be in. So let's say the arc length is 10 centimeters. And let's say the radius is 20 centimeters. What happens with those centimeters? They cancel off. So my answer is going to be 0.5. Now, let's think about this. Every single time we do this fraction, those units will cancel, right? Do you agree? Now, theta is an angle, yes? So I have currently theta equals 0.5. You tell me, is that in radians or is that in degrees? Radians. Why? Because there's no degree symbol. We agree? Yes? So that is going to be in radians because the units will cancel off and we'll have radians, correct? So this is an angle and it always has to be in radians. So how they do a little bit of trickery, and by trickery I mean like making you actually have to do a bit of work, is they'll give the angle in degrees and you will have to convert it. Or if they make you find the angle, they make you give it to them in degrees, and when you use the formula, it gets it to you in radians, right? So you're going to have to convert it. So often they make you convert. The other thing they do sometimes is they'll give you the diameter, which is just twice the radius, so you'll have to divide by 2. Okay? So let's look at the first one. A pendulum, I have to talk about what these things are. So if we look at anything in this format, so it's a piece of the circle, see here's the center, correct? This is going to be my theta, this is going to be my radius, and this is going to be my arc length. So the arc length could be the whole way around the circle if I did a full circle, and then the angle would be too high, right? Okay, so here we have a pendulum 30 centimeters long. So here's our pendulum. It's 30 centimeters long. It swings through an arc of 45 centimeters. So let's label these. This is my radius. This is my arc. And they have to be in the same units. I've never seen it where they're not, but if they aren't in the same units, you would have to convert them to be in the same units. Okay? Because we need those units to cancel off to get radians, correct? So they want the answer in, so through what angle does the pendulum swing? Answer in degrees and radians to the nearest tenth. So we would say theta equals A, which is 45 centimeters, over radius, which is 30 centimeters. So theta equals 1.5. 1.5 what? Radians. You can put nothing. You could leave it as 1.5. But it's not as obvious to people that it's radians unless you put rads or radians. So it might help you out that if you put the 1.5, that you put radians behind it. Because remember, if it's theta equals something, and that has to be in radians or degrees, those are the options, because that's an angle, correct? Now we need to also get it into degrees as well. So if I want to convert to degrees, what would I do? Times 180 degrees. Divide by pi, so I get the degree symbol at the top, right? So type that into your calculator. And you get 85.9. Now some people will say to me, Mrs. Lepp, what mode do I need to be in? Are you pressing the sign, the coast, or the tan button? No. So do you need to be in a specific mode? No, it's just those 3 buttons. You guys try B. Okay, so we have theta equals the arc length over radius, and we need to calculate the arc length. So A equals theta over R. Now, they will have the answer to you putting 150 degrees in there. They'll have that answer, right? Common error, not actually putting in radians. But remember, theta has to be radians. So 150 degrees. I need the degree symbol to cancel. So I put the 180 degrees on the bottom, and then the degree symbols cancel, and the pi to be on top. And I get 5 pi over 6. So I get 5 pi over 6 times the radius, which is half of the diameter, 4.6. And I get 12.0 centimeters. You guys can work on number 7. Remember I told you you can't do number, you guys know. You can't do number 7 on 4.1, that homework. You now can do number 7. Okay? Meters.